Hello, good evening. Am I audible?
സ്ക്രീന് വിസിബിൾ അല്ല. വീഡിയോ ഓക്കെയാണ്, ക്ലിയർ ആണ്. സ്ക്രീന് വിസിബിൾ അല്ല. ഓഡിയോ ചെക്ക് ചെയ്തൊന്ന്.
Reshma, can you hear me?
Yes, I can hear you.
Yeah, okay. Let me know whether screen is visible or not.
ഇറ്റ്സ് വിസിബിൾ.
Okay.
Yes, yes.
Okay, so we can start today's session. In between, if someone is joining, let them. Okay. So, good evening, everyone. My name is Sri Lakshmi. I am a third year PhD scholar in IIT Bombay. So, I will be taking the tutorial sessions for this course, Principles of Organic Synthesis, which is taken by Professor T. Punniyamurthy from IIT Guwahati. Okay. So, this is the overall course layout of this course Principles in Organic Synthesis. So, I will be discussing today the week 1 lectures in a brief, that is the formation of aliphatic carbon carbon bonds, base catalyzed reactions. And in the coming weeks, we will be discussing these other topics. And these are the references which you can follow to read more about these topics. Okay, so we know that base catalyzed reactions means a wide range of organic compounds is capable of forming carbanions. Like if an electron near to an electron withdrawing group like carbonyl group or nitro group, carbon is having proton, it will be acidic in nature, and that proton can be abstracted by suitable base, and then the carbanion will be generated, and this carbanion can undergo different types of reaction like Michael reaction or addition reaction, substitution reaction. So this is the basic scope of this base catalyzed reactions. So we will be briefly discussing which all reactions we have seen in the lecture 1 and lecture 2. After that, we will be moving to the problem solving session. So the first reaction which we seen was aldol reaction, and then we saw aldol condensation as well. So aldol reaction is basically the carbonyl group, that is an aldehyde or ketone having an alpha hydrogen in presence of a base, it will be forming this beta hydroxy ketone. Further, if we are heating this, it can undergo elimination of one molecule of water to form alpha beta unsaturated ketone, and that is known as aldol condensation. Okay. Then, then we have also seen the difference between kinetic enolate and thermodynamic enolate. So, kinetic enolate will be formed basically by using strong bases like LDA, and moreover, it will be formed at lower temperature and in short reaction time. So, kinetic enolate means the base will be abstracting proton from less sterically hindered position. And in the case of thermodynamic enolate, we will be using a weak base, and it need higher temperature and longer reaction time to form this thermodynamic enolate, and it will be forming more stable enolate as compared to the kinetic enolate. Then we have also seen the diastereoselectivity of this aldol reaction. Like in the case of aldol reaction, there is a possibility of like four stereoisomers, which depends on the transition state. A six-member transition state will be uh, Lakshmi.
Yes, ma'am.
Yeah.
Madam, why we are saying thermodynamic inlet? Any reason for that? Particularly for the thermodynamic inlet?
Basically, we are telling thermodynamic inolite means it will not be forming usually at room temperature or lower temperature. It need more temperature for that energy barrier to achieve, and then only that inolite will be generated. Because as we can see, it will be abstracting proton from the more hindered position. So that needs more energy. That's why
Okay.
it is
Okay.
called thermodynamic inolate, and it will be more stable as compared to kinetic inolate.
But when we are seeing the reaction equilibration,
Yeah,
it is less forward reaction compared to thermodynamic inlet. I think unsymmetric ketone is most of forming reaction,
yeah.
but we are saying that more stable form. You are saying so.
More
How it will?
stable, that will be depending on the temperature. It won't be stable in the like lower temperature, but at that higher temperature we can trap that particular inolate, and at that temperature only we can quench that inolate with some electrophiles, and we can carry out the reactions. So at that temperature that will be more stable.
Okay,
Yeah.
fine.
Okay.
Thank you.
So then we have also seen some reactions. Oh, okay, we were discussing on the diastereo selectivity. So basically, like four diastereomers are possible, like syn or erythro, trio, anti. And if Z-enolate is forming, we can say more like mostly it will be resulting in syn product. And if E-enolate is forming, mostly it will be resulting in anti product. Then we have also seen some reactions based on this aldol reaction, that is nominal reaction, which is the reaction between this aldehyde and ketone. And like here, moreover, we will be using mostly active methylene group having compounds. And then another reaction, I think mechanism also I have given here. Yeah. If you have any doubts in between these mechanisms or anything, you can interrupt me and ask. I'm not going to these details because we have already seen all this in the lectures. Then another reaction is Henry reaction, which is also known as nitroaldol reaction, which is basically the reaction between this nitro compound and aldehyde to give this 1,2-nitro alcohol. Yeah, 1,2-nitro alcohol. So this is the mechanism of that reaction. So then in lecture 2, we have seen this Perkin reaction. That is basically this reaction between this aldehyde, aromatic aldehyde, and this anhydride, which will undergo a condensation type of reaction to form this alpha beta unsaturated carboxylic acid. And here, one thing we have to remember is that if electron withdrawing group is present in this aromatic ring, it enhances the reactivity due to the increase in the electrophilicity of the ring. Okay, and this is the mechanism for this Perkin reaction. Then another reaction which we saw was this Claisen reaction, where this a beta keto ester will be forming, and here we are using this two molecules of ester will be reacting in the presence of the sodium methoxide, followed by this hydrolysis will give this beta keto ester. So first the deprotonation of the alpha carbon will take place, then this will attack the second molecule, and then this yeah OET group will be leaving, and we will get this beta keto ester. Then the last reaction which we seen was this Thorpe reaction, where this molecules of nitrile, that is functional group will be CN there, and that will be undergoing an aldol type of reaction. First this base will abstract proton from this group, and then it will attack the second molecule, resulting in this kind of compounds which is known as Thorpe reaction. So that was the basic introduction about the all the basic idea about all the reactions which we have seen in the lecture 1 and lecture 2. Now maybe we can move to some problem solving. Let me check whether someone else is there for joining. Okay. Okay, so you can try doing this. We all know this. This is a basic reaction. So predict the product of the following reactions. Two molecules of acetaldehyde in presence of H plus or OH minus. Which will be the major product, and let me know which reaction it is first. If anyone can unmute and answer. Reshma, can you hear?
So I can hear you. One
Yeah,
second.
you can try and then answer this.
Actually, I'm having a doubt. I was typing it in the in-call message.
Okay, okay, you can ask directly.
Okay, so actually, what a base does is it abstracts the most acidic hydrogen in the particular group or
Yes,
the molecule.
yes.
So how can we know which is the acidic hydrogen in the group, like the molecule?
Okay, that is a different topic actually, like based on it depends. Like if carbonyl group is near that, then the proton will be acidic near to that. And then in the case of like if a nitro group is there, then the proton near to it is it will be acidic. If nitrile group is there, that is particularly electron withdrawing groups will be there, then the proton nearby it will be mostly acidic. And the order of acidity also matters, because if we are using a base, if there are multiple electron withdrawing groups, which proton is easily abstractable also depends. Okay, so mostly the proton near an electron withdrawing group will be acidic. That is the basic thing.
Okay, okay,
Yeah.
thank you.
Madam, first answer
You can
option
explain also
option
which
A.
reaction it is.
It's an aldol condensation.
Yeah, aldol condensation or aldol reaction, both are
All
different.
so aldol reaction.
Yeah, aldol reaction. So the answer is first option, and this is how it is forming. So first the basic, in basic medium also, in acidic medium also this reaction can happen. So if it is in basic medium, this OH minus will abstract proton from the CH3 and this enolate will be forming. Then this negative charge will come back and this double bond can attack the next molecule of this acetaldehyde, and this will be forming. Then this O minus will take the proton from the water, and during hydrolysis or during workup we will get this compound. So is it clear?
Yes, ma'am.
Okay. Others, Amrita, Ishmeet, Reshma, is it okay?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Okay, we'll go to the next question then. The major
Madam,
product.
sorry to dis.
Yeah, yeah, you can tell.
Madam, there is a PK value 13.5 we are mentioning. No,
Yes,
what is
yes.
the necessity of that PK value? Sorry, I'm not.
Like depending on the pK value, like we are selecting actually bases depending on this pK value. Okay, like if a base is having that pK value less than this 13.5, that will not be able to take this proton.
Okay.
So that is the
So
basic.
near to the PK value 13.5, we have to choose
Yeah,
it.
near or above that.
Above that,
Yeah,
okay. Okay, fine.
yeah.
Right.
So next question, the major product formed in the reaction given below. Try this. If you can answer, it is good. Actually, this reaction particularly, sir didn't mention in the lecture, but the concept is more or less similar only. If you are not able to reach up to the answer, that's also okay.
I think first answer, ma'am.
We'll see.
Okay.
You can tell how it is forming.
Uh,
You can try. It's okay.
it's okay. I think the Br, the CH3 ketone nearby that proton is having, yeah, their proton, it will come out. So HBr it will come out.
Okay.
So and here phenyl and phenyl oxide will come out. So phenyl group will go and attach it to the carbonyl group.
Okay. But
So then,
here, what is the need? We are not using any base, right?
okay.
We are using here zinc and acidic condition.
Mhm.
Have you heard about Reformatsky reaction?
Yes, yes, ma'am.
It is based on that.
Okay.
So you guys are doing MSc?
So I'm doing PhD actually
Okay.
very long back.
Okay.
Right now, almost 12 years over right now. I
Okay. So you
complete.
can brush up all these things.
Yes, yes, I
Yeah,
have
yeah. Mm.
because of the now I am working in the pharma industry. So
Okay.
completely, it's now new for me
Okay.
again. I'm
Yeah, it's okay.
learning the things. Right.
Okay, I will show you what is happening here actually. This zinc can coordinate with this oxygen, and this halogen can go to this zinc like this OZNX, and that is how this enolate is being formed. Enol form is being formed. So this is the intermediate that is forming with this substrate and this zinc. Okay, then this will attack with the second molecule, that is this ketone, which is not having any alpha hydrogen. So this will be attacking here, and this will go. So it will be forming this kind of intermediate, which will upon hydrolysis will give this product. So the answer is option B. Is it clear, or should I explain it again? Actually, this is a kind of oxidative addition. We can say this bromide is getting, the zinc is getting oxidative addition here. So here it will be Z and Br first forming, and parallelly it can coordinate with this oxygen also. That's
Actually,
how
I
this
have a
is leaving.
doubt. Like,
Yeah, you can ask.
bromine is a better leaving group, right? So why can't Z react with bromine and take away as ZBr and there is a formation of alkene bond?
Yeah, that is also forming, but zinc have more affinity towards oxygen. That is what is happening basically. Bromine is a living group here, and it is living and it is going with the zinc. But that zinc can coordinate with this oxygen and thereby stabilizing the phenol form. So that is what is happening. So once the phenol is formed, then it is simple like our normal aldol reaction. Is it
So
okay?
actually, how can we know like the zinc will form enol with oxygen, and how can we learn these concepts? Like when we see BR,
Yeah,
obviously what I thought is and BR, it will eliminate as and BR.
yeah, is it
Uh,
NBR? And then what will happen next? If it
Actually,
is
I had solved this problem. Like
okay.
assignment zero was given, right?
Yeah, yeah,
So
yeah.
I
It is
solved
from
the
that
problem.
only. Mm.
In that also, I have like and BR leaves, and then a double bond is formed with OH like that. So my answer was actually option A. So maybe like my perspective was different.
Option A, but okay, sudden BR is leaving and here double bond is forming, the enol form is generating. But then the problem is that here this phenyl is not a living group.
But carbon is electropositive, right? The C that the double bond or that double bond gets shifted to oxygen. Not possible.
I didn't get. Can you speak little louder?
Okay,
Your
it's
voice.
okay. Actually, my throat is. I'm having
Okay,
a
okay.
sore throat, so okay,
So,
it's fine.
you are telling like this will exist as ketone and double bond here as well?
Enol, keto enol form. It can form
Yeah,
keto enol.
ketoenol form means here it will be like OH and here it will be double
Yeah,
bond, right?
yeah. That double bond can go and attack the pH double bond or
Yes,
pH.
yes.
That
Huh.
C is it is electropositive, right?
Yes.
So
Here whatever
this
double
can,
bond will be
yeah,
forming that will be
can go
attacking
and
here.
attack this.
And this bond
So
will shift to here.
yeah, yeah,
Yeah.
yes, exactly.
Yeah, that is what is happening. And then while doing so this will be in O minus form, right?
Yes,
Then it will be converted into OH during workup or in acidic condition it will be converted into OH.
OH.
Yeah. So
And
you are going in the right way. I just introduced you to the basic concept of this Reformatsky reaction. So be familiar with the name. Like if we are using this bromo ester compound in presence of zinc, that type of reaction is known as Reformatsky reaction. Okay. Okay. I hope it's clear.
Yes, ma'am.
Yeah. So next reaction, predict the product of the following reaction. So here this one chloroester kind of compound and this acetone in presence of sodium methoxide. I hope you all have solved these problems in week 0 assignment. So here we have to know first sodium methoxide, which proton it will be abstracting first. Reshma, can you try this?
actually, I've written, but I'm not able to
Yeah,
recall.
which one you got?
I have written. No, I couldn't get the fact. I in an answer. I guess the answer is D. D and D is the answer, I think, but I don't know exactly how it works.
You can try.
I don't
Yeah,
know.
D is the answer. So you can now see how it is happening.
See, chlorine is a better leaving group. Again, that concept came to my mind.
Yeah, it's happening. So from where first proton abstraction will be taking place?
Next to the chlorine, CH2 is
Yes.
there, no?
So
It's
here
because
first proton
chlorine is
abstraction will take
electron.
place and here one carbanion will be generated. So someone has answered option C. Can you explain how you came into that answer?
Okay,
Yeah.
madam. First, base removes alpha proton from chloroester.
Yes. Okay. So carbanion will be generated here.
Yeah, that
Okay.
carbanion reacts with estophenone.
Uh, Here like this.
Like that,
Okay.
oxygen becomes negative charged oxygen.
Okay.
In second step, SN2 reaction takes place.
Yeah. SN2
Chlorine
reaction.
displaced there.
Yeah, so what will be forming if SN2 reaction with what it is happening? Like here O minus is there, right?
Yeah, that O
So
minus
will go and attack here
there
again.
and the chlorine will be displaced there.
So it will be option C or D then, because
That
what
is C, option C.
C is actually cyclopropane, but here we are getting
Yeah,
O
yeah.
C.
Last D option,
Yeah,
D option. Okay,
so
thank you.
D will be the answer. Is it clear, Reshma?
Yes, clear, sir.
Yeah.
Okay. I hope it's clear. So first proton abstraction will take place from here, and this will attack this carbonyl group, and here this O minus again will attack the same center, and Cl will knock out in SN2 fashion, giving this epoxide. Okay. So the next question, the major product formed in the reaction given below. So here a diester is given, that in presence of the sodium methoxide and ethanol, what will be happening? So which reaction it is? This is a named reaction.
Dickman.
Yeah, Dickman condensation, or
Dickman.
yeah, Dickman reaction. So which is the product?
Product is A.
Product
B.
is
B.
B. A, B. Different options are there, opinions are there. So first,
B. Option is B.
okay, yeah. So how it is happening?
This is intramolecular Claisen condensation.
Yeah.
First, proton is removed from alpha carbon.
Okay,
A
let it be here.
carbanion is generated.
Huh.
That carbanion attack on carbonyl carbon of second ester,
Yes.
followed by elimination of ethoxide ion.
Ethoxide. So one,
Uh,
two,
a
three, four, five.
cyclic, yeah, 5-membered ring is formed.
Yes.
Keto and the ester groups are in adjacent position.
Yes. Yes. Okay. So I think it's clear for all.
Yeah.
So the next question, this was the last question of week 0 assignment. Predict the product of the following reaction. So this ketone and this secondary amine in presence of acid, what will be forming? It's a very simple reaction, right?
This is in amine reaction.
Yes. So how it is basically forming?
It is first amine act as nucleophile that attack
Yes.
on carbonyl carbon.
Yes.
Carbonyl carbon converted into OH group,
Yeah.
followed by elimination of proton.
Hmm.
More substituted double bond will be produced.
Yeah. So this is the answer.
C option.
Yeah. And it is going through this one.
Actually, I'm having a doubt.
Huh.
Like, while I was solving this problem, option C with the double bond attached to the like substituted E, right?
Okay.
So, like one of the professors said that in alkenes with substituted things are more stable than without substituted.
Huh, mostly we say like that, but I also have little confusion here. Like A or C,
But
right?
when we check in the Google, like regarding the stock enamine foam,
Yes, mostly this is getting
it is
forms.
giving,
Yeah.
but one of the professors said that like substituted alkenes are more stable.
Huh. I
So
think the reason is that here you can see here in this mechanism, once like yeah, this intermediate is formed, then the proton, that carbon proton that is getting transferred to here, and that is forming this double bond, right?
yeah,
Like two options are there, one, this bond can shift, or this bond can shift, right?
yeah,
So if this is shifting, double bond will be forming here. So I
yeah.
guess the reason is that since hindrance is more in this side, maybe that is more accessible.
Actually, the same thing only I guessed, but
Yeah,
the
yeah.
professor was telling no that substituted alkenes are more stable. So that
Substituted alkenes are more
alkenes are
stable.
more stable.
Yeah, I will read about that and I will let you know in
Yeah,
next session.
yeah,
Yeah.
yeah. Maybe you can just give us a correct.
Yeah. Checked in book also. It is given option A, but your question is right. Mostly we will say more substituted alkene will be more favored. But I think the reason is the steric hindrance only, because the proton abstraction will be more difficult due to the presence of this methyl group. But I will go through this and I will let you know.
And like, can you please tell why substituted alkenes are more stable? I need to know why it is more stable.
Like that, pi orbitals will be more stabilized with that electrons. That's why
Okay,
we say usually, like if carbon carbon substitution is there, that will be more stabilized.
okay, thank you so much.
Yeah. So that was about the week 0 assignment. Now we will move to some other questions which is also based on the lectures.
Excuse me, ma'am.
Yeah, you can tell.
Ma'am, can you please explain this mechanism like from the third step?
From the third step means from here.
Yes, ma'am.
Okay, so first, what is happening? This ketone, in presence of acid, that oxygen will have affinity towards the proton, so it will form this intermediate. Then this nitrogen lone pairs will attack here, and this is forming. Up to there, it is clear.
Yes, ma'am.
Okay, then what is happening? Proton shift is happening because this N is having already one positive charge and four bonds are there. So what will happen? This proton will shift to this oxygen again, because oxygen is again having lone pair, so it will again have affinity towards more proton, right?
Okay, okay.
So that will stabilize this positive charge on nitrogen as well when this hydrogen is going. So here it
Okay,
will
ma'am.
form
Okay.
OH2 plus, and here it will be stabilized nitrogen with three bonds and one lone pair. Then this OH2 plus, that is water, it can leave out as water molecule.
Yes,
So
ma'am.
this nitrogen lone pairs will fall here and this will leave out as water molecule to give this. Okay.
Okay, okay, ma'am.
Then
Okay, ma'am. Thank you.
I hope this is clear. Just proton, this
Yes, ma'am.
proton will go and again this will be stabilized to give this enamine.
Yes, ma'am. In a minute.
Okay.
Okay.
So the next question, the major product of the reaction. So here also diester is there. So we have seen similar problem before as well, in presence of sodium ethoxide and then followed by hydrolysis. So again, which reaction it is?
Dickman condensation.
Yes. So which will be the answer?
B.
Option B. Yeah.
Ah,
Mechanism, I think it's clear, right? We have already discussed this.
okay. Yes.
Yeah. First, proton abstraction will take place from this position and it will
Ah,
abstract this carbonyl and OET will be leaving. Yeah. Through the stable enolate, it will form this product. It's
I
okay
have
for.
one doubt.
Yeah.
Like in previous reaction, there was no reaction condition, 80 degrees Celsius, and also will this affect like 80 degree? Yeah, understood my question.
No. Can you repeat?
Okay, in the previous different reaction, only NaOE2 was given and
Yeah, this
ethanol.
one, right?
But now, in this reaction which we are discussing, we have given reaction condition as 80 degrees Celsius.
Yes. So,
So, same only, right?
but
Same
here,
reaction.
actually, they haven't mentioned any temperature or any other condition, right here.
Okay.
So we don't know at what temperature they are carrying out this reaction, but here, since there is no other possibility, we are expecting only Diekmann condensation in presence of base.
Okay.
So
So,
here,
like, if we vary the condition, like for instead of 80 degrees Celsius, what if we form it in 0 degrees Celsius and all?
0
Just a
degrees
like
Celsius,
I'm
yeah,
just
might be the reaction won't work. Like
will change.
a reaction, maybe it won't work. Like we need this Diekmann condensation, right? Like, yeah. Firstly, this proton abstraction may be hindered. That's why they are using 80 degrees Celsius. It might be not much accessible. So we need to heat the reaction mixture. Then only this proton abstraction will be taking place. Then only it can attack this carbonyl group. So not always we need 80 degrees Celsius. So if we are carrying out a reaction, always we need to optimize the reaction conditions, right? So
Yeah.
first we will try the reaction at RT. If it's not working, we have to heat the reaction mixture. If multiple products are forming at RT itself, we have to reduce the temperature and see, like with temperature we can control our desired reactivity or not. Like that we have to optimize. So might be this is one of such optimized reaction condition.
Okay. I can just ask.
Yeah, yeah, fine.
Use
Okay. So the next question is here the major product of the reaction. So this compound in presence of this potassium tertiary butoxide and THF, what will be happening? So here also we have to know which proton will be more acidic. So base, which proton will be abstracted by this potassium tertiary butoxide.
Proton should be removed from adjacent to cyanide group
Yes.
because it is more minus I group.
Yes, yes. And then what will be happening?
And Dickman condensation
Hmm.
takes place
Yes.
here also.
So the answer will be
Here, D.
answer will be option D. Yeah. So first it will abstract proton from here, then it will attack this carbonyl group and OMe will be leaving to give this product.
Answer is option C, right? The stereochemistry,
Option,
hydrogen.
yeah, yeah, stereochemistry also matters here. So yeah, actually this is already existing stereochemistry in the molecule, right? All stereo centers are previously existing in molecules, so this will be option C will be the correct answer. Cn is already here in beta proton. This proton is coming from, I guess,
Eliminated, right?
yeah,
CO.
yeah, it's eliminated. And this methyl also same. Yeah, so C will be the correct answer. The next question is here one active methylene compound is there, then one alpha beta unsaturated compound is there.
In this, how can you know which is the most acidic? Right?
Here, like active methylene, have you heard about active methylene compounds?
Yeah, yeah. I just heard it, but I don't remember
Yeah,
exactly.
active methylene compounds means like this type of compounds we call active methylene compounds, because
Yeah.
as we can see it is highly acidic because of two electron withdrawing groups on the both sides.
Okay.
Okay.
The product is A.
The product is A. So what is happening here?
First, diethyl ester lose a proton, converted it into a carbanion,
Yeah, here.
which attacked to first molecule at ethyl position,
Yes.
followed by double bond shifting.
Double bond shifting and here enolate
Enol
formation.
is produced,
Yes.
and enol rearranges to ketone
ketone.
again.
Yes.
Uh,
So it is like 1,4 addition. It is happening.
yeah,
So actually, why it is not attacking the carbonyl carbon?
Huh.
1 4 addition.
1,4 addition is happening because here we can see there is an extended conjugation right here in this molecule.
Yeah.
So this position will be more favored rather than this in that case. So we call this type of reaction Michael addition.
Ma'am,
Okay.
is there the concept of hard soft?
Your voice is breaking.
Ma'am, is there the concept of hard and soft centers?
Yeah, that's also there. So basically, this is which sender, hard or soft? Hello. So
Ma'am, is there the concept of hard
yes,
and
yes, I
soft centers?
got your question. So this is hard sender or soft sender? So these carbonyls are
I don't
basically
know.
hard senders, right? So here this sender will be
Carbonyl
yeah,
carbon is the hard
hard
center.
sender. Yes. So this is basically a soft interaction happening here.
Okay, okay, ma'am.
So this is the mechanism. I hope it's clear. Now this one. So this particular compound in presence of 2% NaOH in methanol, heating condition again, so which will be forming.
Option D.
Option D, yes, and the reaction is
Here,
hmm,
this is the aldol condensation.
yes.
Intramolecular aldol
That is
condensation.
big man.
Okay, okay. Here, proton is removed from methyl group
Yes. Why?
because it is more stable carbanion here
Hmm.
and more acidic.
More acidic. So what will happen if it is forming carbanion here?
It undergoes synolization.
Yes.
Uh,
Enolization, and one other thing is that if it is undergoing deep
600
band condensation, it will be forming one, two, three, four member ring, right? Four.
from outside, it is taken from outside.
Yeah, so it is taking from
Uh,
this one.
that gives a 6 membered ring.
Yeah,
Six
six
membered ring
membered
is
ring.
more stable.
More favored. So we will be getting this one. Now the next question is this one, major product of this reaction. So one aldehyde is here and this nitrile, this ester is also there. So what is happening here?
Please explain this question.
Okay, any others? So from where proton will be abstracted first?
From cyanide molecule.
Yes. So here carbanion will be generated. Then what will happen?
That will added to carbonyl group,
Which carbonyl group? This aldehyde,
aldehyde
right?
group.
Okay.
First.
So this
Ma'am,
will
is this also a active methylene group?
Yes, yes, it
Is
is
this
active
also
mechanism.
active mixing?
Because cyanide is also strongly
Okay.
electron withdrawing, and here also ester group is there.
Yes, ma'am.
Yeah.
Okay.
So first that addition will be giving this intermediate, and since we are yeah, then here one proton is there that will go along with this OH minus, one molecule of water will be eliminated to give this compound. So answer is this one.
Okay, thank you.
Yeah. So this is Novanagal condensation reaction. Is it clear?
Clear.
Okay. So the next question is the major product of the reaction is. So this I think we have seen in the lecture video as well, in presence of lithium hydroxide and this aldehyde.
It is
Which one?
option D.
Option D. Okay, we will see. Yeah. So basically, what is happening here?
Proton is removed from cyclopentanone.
Yes. So here, if it is removing,
That will added to isopropyl
yeah.
carbonyl group.
And here, one more thing we have to consider is the stereochemistry.
Yeah, stereo.
Yeah. So basically, which enolate will be formed here first, E or Z? Because this is a cyclic compound, so there is only the possibility of one enolate, right?
Yeah.
Yeah. So which
Z, Z, Z only.
Z or E?
The opposite one. E enolate.
Yeah, sure.
E.
Yes, yes, ma'am. The
E
opposite
enolate
one.
is
E
forming
enolate.
here. So E enolate will be giving which one? Anti-product, right?
Anti-product.
Yes. So the answer will be this one. Option B. So it is basically going through this intermediate. I think we have seen this in this lecture video. The six-member transition state will be forming with this lithiated species and our aldehyde. So considering this is in equatorial position and this proton is in axial position. So 1, 2 axial equatorial means it will be which one? Anti, right? Transit will be. Is it okay? So basic thing we have to consider is that which enolate is getting formed, E enolate or Z enolate. So if there is the possibility of formation of both the enolates, then we have to see which base we are using. Then we have to see kinetic enolate is more favored with that base or thermodynamic enolate is more favored in that case. But here anyway, there is no such confusion, only E enolate is favored. Is it clear?
Okay, clear.
I hope it's okay. Yeah.
Yes.
So the next one, the major product of the reaction. So here also one keto ester is there and this dibromo compound is there in presence of sodium methoxide and ethanol. What will be happening?
This is option D.
Option D. Okay. Any other chances there other than option D?
Option A, is there any chance?
B also B possible.
Okay. So A is there, B is possible, D is possible, but the answer is C. So I guess option D, whatever you said, that is like first through this only, right? Can you explain how you told about this option D?
Yeah, first a proton is removed from ketoester
Okay.
that reacts with bromo compound.
Yes.
First option is produced,
Huh.
followed by removal of one more proton from the ester, ketoester.
Hmm.
That also undergoes intramolecular SN2.
Okay, so what you are
Bromine,
telling is through this compound, right? So this
yeah,
proton is
same.
getting abstracted and
Again,
huh.
SN2 reaction takes place.
Yeah, so here enolate is forming and that is attacking here, resulting in
Uh,
this one.
yeah,
But that will be happening if both sides there was ester. Okay, so here
uh,
what is happening is first this is forming. As you said, first this is forming, and
yeah,
then the second enolate is also getting generated. But what is happening is that this whatever O minus is forming, that O minus is attacking on this in SN2 fashion, and bromine is leaving.
okay, okay.
Okay,
Thank you.
so if it was ester on both sides, this O minus will not be that much attacking on this SN2 fashion. It cannot attack that much. That enol will be not that much stable. But here in this case, it is attacking with through oxygen. It is attacking, not through carbon. So first C alkylation is happening, then O alkylation is happening here.
Okay.
Actually, why is the proton getting attacking again? Like in option A, once the HBr elimination happens, then why is that proton again?
Because as you can see, if this proton, like already this is very acidic in nature, right? One side keton is there
Yeah,
and one
yeah.
side ester is there. So if one more substituent, that one alkyl group is coming here, it will be that carbanion whatever is generating will be more stable. This compound will not be stable like this form. It will have the tendency to lose that proton as well. It will be too much acidic. Yeah, so we cannot control the reactivity up to this stage. Okay.
And then why is the carbon like C double bond O minus is attacking near because of the electronegativity of bromine?
Yeah, electronegativity of the bromine in SN2 fashion, because bromine is a good living group. Again, one more
Yeah.
bromine is here in this compound. So it can undergo two fashion, like either C alkylation can happen, that will give this one, or O alkylation can happen. But since this is a ketone, O alkylation will be more favored. If it was ester both sides, then we can expect this compound.
Okay,
Okay.
thank you.
Yeah. So this is an example of alkylation of 1,3-dicarbonyl compounds. So this is happening. Mechanism I have given here. Same whatever we have explained. Okay. Next one, the major product of this reaction. So this nitro compound. First we are treating with NaOH and acetaldehyde. Then in second step with H2SO4 and water. So what will be happening here? Which reaction it is? Actually, this first step is one named reaction. Second step is another named reaction.
Yeah. Option is A.
Option is A. Any other options are there? Any other possibilities? Okay, so you can explain how it's forming.
In first step, proton is removed from nitro group
Okay, so
because that is more acidic.
yes.
That added to aldehyde group.
Okay.
We get to beta hydroxy compound, aldol condensation type reaction.
So we have a name, right, for this nitro compounds, aldol reactions in nitro compounds, nitroaldol.
Yeah, nitroaldol.
Henry.
That is
Which reaction is Henry reaction?
Henry.
Yeah.
Oh, followed by treating with acid.
Hmm.
Under this condition, OH group is removed.
Okay. So you are expecting like water molecule will be leaving and we will get this double bond there.
Yeah.
But here what is happening is that, have you heard about NEF reaction?
Yes, NEF reaction.
Yeah, so this nitro is basically getting converted into ketone in presence of this acid.
Isomerization.
Yes, so what is happening is that first step is Henry reaction and second step is NEF reaction.
Oh,
So this is the basic mechanism of NEF reaction. So this nitro compound, whatever we are getting after this aldol reaction, so in presence of acid, this nitro will get protonated, and then water molecule also we are using with acid here. So that water molecule will attack this carbon, and this bond will shift here to give this intermediate. Then again proton transfer will take place to get this intermediate, and then this nitro will be a good leaving group here, and that will leave, and here we will be getting this ketone as the major product in presence of acid. Okay.
okay.
Yeah, so Henry reaction and NEF reaction, two reactions. Now the next question, the major product of the reaction, here one ketone is there, then we are using the secondary amine in presence of MVK. MVK is methyl vinyl ketone, and in second step sodium acetate and acetic acid. So methyl vinyl ketone is basically this vinyl group, then ketone here, and here one methyl group. So this is MVK. This is also a named reaction.
This is Michael addition reaction.
Yes. So first aldol reaction and then Michael addition.
Yeah.
Right. So
Yes.
we combinedly we will call one name for this reaction. Aldol condensation followed by Michael reaction. It's called Robinson annulation.
Enunciation.
Yeah. So which will be the product?
Product is C.
Yes. So how it's happening?
First, aldol condensation takes place with methyl vinyl ketone.
Yeah. So here negative charge will be forming, and that will abstract here 1,4 fashion.
Yeah.
Yeah. And then
Next, in second step, proton also removed from added molecule.
yeah. So from where it will be this methyl group, right?
In first molecule at methyl position,
Yes.
cyclohexanone
Uh,
methyl.
like we are
Actually, no. First, methyl vinyl ketone is added to ketone molecule.
methyl vinyl ketone is added to ketone molecule. How?
Cyclohexane.
First, what is happening is basically aldol reaction only. Like proton
Yeah.
abstraction will take place, and then in 1,4 fashion, this will attack here, and this will go here, and this will go here. Okay, and
Um,
why we are using this one, this
that
secondary
is
amine?
base. That
Base
can.
also, and it can form enamine, right?
Yeah.
Yeah. So I will show that. So first what is happening, this will form that enamine, that is this one, and then this will attack on this in 1,4 fashion, and that will form this one. Then again what is happening is this proton is acidic, so this will abstract proton from here, so it will be CH2 minus, so it will attack here forming that 6 membered ring. So here it will be OH, Then that water molecule will be eliminated to form this. Is it clear or should I explain once?
Clear, madam.
Actually, why is the double bond of the enamine attacking double bond in the vinyl?
Double bond of
Uh, MVK. That
MVK, like whatever we see in the case of enolate, right? Like here,
yeah.
if one carbanion is generated here, what is happening is that this will shift to here, and here it is forming O minus.
Yeah, O minus.
And
Yeah.
through that double bond only, it is attacking this MVK, right?
Oh, so you have
Same thing
just
is
direct.
happening here as well.
No, but there is no carbonyl group or anything,
Carbonyl
right?
group is not needed. Actually, this is
Uh,
enamines are more reactive than carbonyl groups. That's why first we are converting this ketone into this enamine, and then it is undergoing this aldol reaction. So that is the use of the secondary amine in particular. It will form this kind of enamines, and that is more reactive towards aldol reaction.
okay, thank you.
Okay, moving to the next question. The major product of the reaction. So here is a dinitrile compound is there. In presence of LDA, THF, what will be happening? So which reaction it is? We have seen in lecture, right?
Yeah.
Mm.
This is Prop reaction.
Yeah, Thorpe reaction. So
It is first option.
first option, how you can explain?
If LDA removes proton from alpha position of one of the nitrile group.
Yes,
That carbanion added to second cyanide.
yes.
C triple bond changes to C double bond N.
Yeah, C double bond
Here,
and yeah, NH it will be.
a four-membered ring is formed.
Yes.
Double bond N on hydrolysis that removes.
It will not be like what is happening here is during
Water is
workup.
absent.
Huh?
Water is absent in the reaction.
Yes, yes. Water is absent, but anyway, we will be doing workup, right?
Tautomerism takes place.
Yeah, so this
So
will be the
second
product.
option will become
Yeah.
correct.
So base catalyzed Thorpe reaction it is.
Prop reaction.
It's clear? Okay, so today I have added this much questions. Total 15 questions we discussed. Maybe from next sessions I will consider adding more questions because we have time
Okay.
remaining. Okay.
Okay.
Yeah.
Can
Okay,
you
ma'am.
send these questions to our mail?
Actually, I will upload this in Drive and that link will be provided to you.
Okay, thank
Yeah,
you.
the slides and this recorded video also you will get.
Okay, thank you.
Yeah. So if you have any other questions, you can ask.
No, no, madam.
Yeah.
Please suggest one book to reference to study.
Reference basic book will be Claydon. That will be enough for all this concept.
Okay.
Then you can use Caruthers as well.
Okay.
Yeah, these two will be mostly enough for all the lectures we are dealing with. Claydon and
Okay.
Caruthers. Yeah. I think I have given the reference in the first slide. Yeah, this three you can use. Caruthers, Modern Methods of Organic Synthesis, Claydon Organic Chemistry, then Carey and Sundberg, Advanced Organic Chemistry. These three books.
Okay.
Yeah.
Thank you.
Okay, if there is no more questions,
No more.
we can conclude today's session.
Okay, ma'am.
Yeah,
Actually, one doubt.
yeah, you can ask.
Like, how do you remember all these named reaction? Like, when you see a reaction, how come it strikes that this is the particular reaction?
Yeah, it's actually a little difficult because we can remember aldol reaction, right? So if basic like acidic proton is there and a base is being like acidic proton is there and a base is being used, that base obviously can abstract that acidic proton. Then that enolate whatever it will be getting formed, it should get quenched with some electrophiles, right?
Yeah.
So that is a basic reaction, aldol, and all this come under the category of this aldol reaction only, and it's not much easy to remember this. Once we are used with solving all these questions, then automatically we will be used with that and we will remember the names. So that practicing only will help in remembering these names.
But like whichever reaction where the base abstracts the acid, it is not aldol, right? It is just part. Is it aldol? Like every
Everything is
reaction,
not aldol. If it
not
is,
aldol.
yeah, if it is again attacking on one carbonyl group, then it can give aldol product. That case it will be aldol. Or if it is attacking like alpha beta unsaturated compound, we will call it Michael addition. Or like if it is forming this kind of six rings, it is forming, we will call it Robinson annulation. So once we are used with this, then only it's easy to remember. So if you are asking me also after 1 month or 2 months, I may not be able to recall if I am not going through this continuously.
Mm.
So continuous practice only will help in remembering the named reactions. Maybe we can try, if we are seeing one base, we can try the mechanisms, but remembering names is not that easy.
Okay, thank you.
Yeah. Okay, so meet you all in next session then.
Thank you, ma'am.
Yeah.
Thanks for your
Thank you
time.
for joining. Thank you.